Alright guys, we'll get started in just a minute. As you might have noticed from the person standing in the middle of the classroom and the big tripod, we'll be recording today's class. We already talked about that. So yeah, we'll just do a quick sound check maybe, and then we'll get it started. Okay. Alright. To look at the logistics first thing. Okay, are we good on sound? All right, we're good on sound. Okay, just give me a minute, guys. Kick this off. Okay. All right, so let's get started. So if you have had a look at the syllabus, today we're going to talk about exception handling. And this is a super interesting topic. It's one of the things that you'll be dealing with almost daily. If you're doing any sort of debugging, which most likely you will be doing as a software engineer in your day-to-day life, you'll be looking at exceptions. And we've already talked about a little bit about how exceptions might manifest. I teased an exception in a way earlier lecture. Hopefully maybe you guys try to explore it a little bit. But today's class we talk about exceptions formally. So let's get started. As is tradition, we always talk about what we did in the class before. So let's look at that. All right, so we talked about solid principles. If you remember, we just finished talking about them. There were two that we discussed. The first one was the dependency inversion principle. The second one was Liskov, but before that we talked about programming by contract. So we discussed preconditions, we discussed postconditions, and we talked about invariants. And of course, the second principle we talked about was Liskov's substitution principle. Both of these principles were a little hard to grasp, but hopefully you guys have a good understanding of that now. With that said, let's start talking about exceptions. All right, so exceptions are usually about when things go wrong, and when do things go wrong. We're going to look at a function we've already discussed in the previous few classes. It's the divide function. So if you remember, we talked about how this divide function would not run for a very particular use case. Does anyone remember what that is? Yeah.
Divide by 0.
Exactly. So when v was 0, this function would actually crash and burn. And we called the condition, the precondition that v is not equal to 0. We talked about that a little bit. And we discussed how when this happens, we actually end up in an error state. Interesting thing about this, so if you actually implement it this way, and you do pass 0, you'll actually get infinity. I'm surprised no one actually told that out. So if you actually do this with ints, then you'll see the arithmetic exception that we're talking about. But anyway. So yeah, we talked about how dividing by 0 makes us end up in an error state, and how, using defensive programming, we can avoid exception. We didn't look at a null pointer exception for divide, and I see that it's pretty hard to read, but we looked at the null pointer exception in a different example. Anyway. So we discussed defensive programming using simple if conditions. So I had this notion of just putting in an if condition in our divide function. So now we're actually checking if b is not equal to 0. Only then do we return the division. Otherwise, we just return some other value. And if you remember, when our precondition is violated, we don't need to honor the postcondition. And that is why we're returning 0, and we don't have to worry about anything. Anyway, And of course, since now it's a valid method for all inputs, this function, when called with any input, will not make our program crash and burn. Do you agree with this statement? Is my question to you. Simple yes or no, 50-50 odds.
That's you.
Yeah, sure. Anyone who disagrees? No?
No.
Okay, someone doesn't disagree. So why will it not crash and burn?
Usually it catches all cases where it would error out if we just make the condition that if it's not 0, then it runs it.
Right, so even though technically we're not honoring our post condition, this particular function is not going to make the program crash and burn. We're not throwing an exception from this function. So why would you say that?
If someone were to use this function later and it would return 0, they might not realize that b is 0, and that would be something, or they're using the divide function in a wrong way.
Exactly. So that is the exact situation where even though we've actually successfully done defensive programming for this function, we still have to worry about whether this particular function will make a program crash and burn. Because remember, whenever you start calling this function from another function, maybe they're dependent on that value not being 0. And if that value is 0, then their preconditions are violated, so they don't have to honor their post conditions, and this begins a cascading chain of failures, which makes your program crash and burn. So on the surface of it, even if you think you're safe with just respect to this function, you might not actually be safe. And that is basically the premise of starting to think about what happens. Anyway, so we've actually already talked about this particular situation. I'm glad someone actually called it out. So this is exactly the situation we talked about, that if you use the divide function in some other place, it might still crash and burn your code. And just to really prove it to you guys, if anyone's still kind of on the fence about it, let's have a quick look at a particular code example. Okay, here we go. Okay, this is the wrong code example, so just give me a second, guys. Okay, so what's going on here? If you remember from last class, we've already kind of talked about this sort of setup. So the dog class still makes a reappearance. That's why we're returning a public static dog. We still want to train a dog that is of this class. If you remember, the dog has a name, it has an age, and it has a boolean which remembers if a dog can shake hands. By default, a dog cannot shake hands. Once it's trained, it can. That was the basic premise. Going back to this. So same sort of setup. We declare a static function called train dog, and we just set the can shake hands parameter to true, and we return it. And obviously, now that we've discussed in the previous class, you remember the problem with this is we're making the assumption, or we have the precondition, that what is the precondition for this one? Does anyone remember? When will this function fail? There's only one input.
B0.
Sorry? I didn't catch that. Okay, Shrugs, is that a raise hand?
No.
Okay, cool. So if you don't remember, that's fine. The only condition where this function fails is when the dog that we're passing in as an argument is null. Right? That was the null pointer exception. Anyway, so now we know that this function is not safe right now, and it is not defensive enough to suit our purposes. Let's look at a function where we do this null check. I'm surprised no one just looked at the board and looked for the null check, but it's fine. Anyway, so now we're doing this null check. If the training dog is not null, only then we do this. Otherwise we return no, because our precondition was violated, we don't have to honor our postcondition. Anyway, so, okay, now we have a similar sort of situation where calling this function will not really make it result in an error in its own thing in the function itself, but it might cause trouble later on, and we'll see what happens. Let's see now in our main class. So similar sort of setup. We're trying to declare a new dog called Scruffy with age 1. I'm going to print it out before and after it was trained. You're probably going to remember before it's going to be can shake hands is false, afterward it's going to be true. That's all fine. And of course, let's say we call this function now, which is our less defensive training dog. Has the null condition, but let's see what happens. Let's just run this. Okay, so the first 2 lines should hopefully be expected. That's what we already talked about. What do we see here? In our less defensive trained dog call, when we put it to some other trained dog, we actually end up with a null value when we try to print the dog. So, in this particular case, you're just printing it, so the program doesn't blow up. But now let's say you implement a new function which takes in that same trained dog and maybe changes the age. And that didn't have this defensive programming. The program blows up because your other functions aren't checking for this, right? Even just calling a simple set, the setter that's included with this dog, it will end up blowing up the program. Anyway, so I propose another function. So this is defensive trained dog because it's a little bit more defensive. And the only difference from our previous function is the fact that we're now printing out a statement when the input is null. That's it. We're just complaining that our input is null. Everything else is the same. We're still returning a null. So we're still not honoring our post condition, but we're just printing it out. Now let's, apologies. So let's comment out these 2 lines and actually call this. Cool. So first 3 lines are the same. These are the 2 new lines you're going to look at. So this time, essentially what happens is, we're still printing out a null, but in our output, we have this message that trainee dog was not initialized. And I hope you begin to appreciate the difference already. So instead of just having this null value print out and you having no clue how that happened, now you have at least a helpful message to kind of tell you, okay, you know what? The input to this particular function was null. And now you can start to look into, okay, so this particular defensive train dog function had some null input, so where do we go from there? You can start your search. That is the demo. So my only takeaway, if I were you guys, was we can do defensive programming, but an even better approach when we're doing defensive programming is to have these sorts of messages. That is it. Okay, let's go. All right. Any questions so far? I think it's hopefully clear. We're not introduced too much, but I'll just stop for just a second. I don't see any raised hands, so let's move on. Okay, so we saw that, of course, error messages are helpful when you're trying to debug what went wrong. And this is where basically exceptions come in. At this point, you might be thinking that exceptions are basically messages that you see when things go wrong, but it actually is a lot more. But this is the basic idea that you want to keep in mind. Whenever you see an exception, you're just looking at a very helpful message to help you figure out what went wrong. Anyway, so let's start talking about exceptions. So that is the formal definition, and it is a very loaded definition. I've bolded the words that actually are the most important. So it is an event which occurs during the execution of a program and disrupts the normal flow of the program's instructions. Event, of course, should be fairly straightforward. During basically is important because you have to remember that it only happens during the execution. And you'll actually see that you actually could have exceptions that happen at compile time. They're called checked exceptions, but this is the official definition from the Java doc written by Oracle. So it's very formal. Anyway, and yeah, normal flow, essentially what they're talking about is, let's say you have a calculator program, right? You want to just do your division, you want to get the answer. Lo and behold, you put in a 0 when you're trying to divide, your calculator blows up. So which one's a normal flow? Obviously the one where you get your answer, not when your calculator blows up. That's what they talk about when they say normal flow. Anyway, so the basic idea of exceptions is they help us understand what went wrong and when things went wrong. I already kind of talked about that. I came up with a sort of analogy. You can think of them as warning bells for a program. Doesn't quite work that way. If every time there's a loud siren, every time you got an exception in your laptop, it would get very old very quickly. But you can think about it like that. And yeah, this is the next point. So for exceptions, obviously we want to avoid things when they go wrong, right? Because who wants your calculator to blow up? But at the same time, when things go wrong, we want to have a plan B in place. So you can't disable the 0 button on your calculator just because you have this problem with your divide function, right? You still want to be able to have all sorts of inputs. And ideally, your divide function deals with a divide by 0 problem in a way where your calculator doesn't blow up and you're still able to manage your day-to-day normal flow operations. So there is this sort of plan B that we want to kind of think about. We won't talk about the plan B just yet. That is a separate concept. We will talk about it today. But first we'll talk more about exceptions. But yeah, the plan B formally is called handling exceptions, and exception handling is the next thing that we'll talk about after we finish talking about exceptions. Anyway, so what you're looking at right now is one little segment of an airplane cockpit. And this particular segment basically is worried about making sure the plane doesn't catch on fire. That's all that this display is actually worried about. So you might see some lights are kind of turned off, it might be a little hard to see, and some of them are on. Well, this is not a picture of a plane that is on fire, this is just kind of a testing that they're doing, so don't worry about that. Anyway, so you can see things like fault over there, something about engine overheating. What else can you think about? You can think about engine overheating on the right too. I'm guessing that's for the left engine, right engine. So when you look at exceptions, you can kind of think about it like that. It's like a console that you're looking at, the program output. And anytime you see a light turned on, or you see an exception, you kind of figure out, okay, things are going wrong. The plane hasn't crashed yet, but it might if you don't take care of whatever is going wrong. Anyway, so yeah, it's just a helpful visualization. Don't think too hard about it if it doesn't make sense. Anyway, so let's talk about exception types. So what things could go wrong? There's two basic types. One is user-defined. So these are things that you specifically say can go wrong. So instead of using the arithmetic exception that might turn up when you divide by 0, you could have your own exception called divide by 0 exception, if that's what you want to say for your particular program. The other type, of course, then is built-in exceptions. So these are already available as part of Java. So this would be your arithmetic exception. And there's actually two types of built-in exceptions. So the first one is a checked exception. So these exceptions are checked for at compile time before the code even runs. So you remember that sort of thing I said about a definition not quite making sense? This is where it doesn't make sense. So you can actually check for exceptions coming up before you even run your program. You can just kind of figure some things out when you compile it. The second then type, of course, of built-in exceptions is unchecked. So these are not checked for at compile time, mostly because there's no way to know if it'll actually happen before you run your program. So these are not checked for at compile time. So here's a nice diagram to kind of summarize the whole thing. User-defined exceptions are what you define yourself. And then there's built-in exceptions, where you actually check for some and you don't check for some. So checked exceptions, examples, you can see class not found. If you're trying to refer to a class when you compile your program and press run, if you don't find that class, obviously you can't run your program. So you can kind of figure that out, that something is wrong before you even actually start running. On the right, you can see examples such as null pointer. We already talked about a null pointer example. We already looked at an arithmetic exception example, and there's a few others. And of course, if something is on the slides, it's fair game. So, hinting about quizzes, finals, all of that good stuff. Okay, before we move on, any questions? See some shaking heads. Okay, cool. If no questions, let's talk about when these exceptions might happen. Okay, so some common scenarios might be user input, basically the most common. Anytime you involve a human in the process, you introduce a whole world of errors. Should be fairly obvious. Anyway, so the next most frequent occurrence of exceptions are logical errors in our program. Remember, we are also human, as much as we might want to pretend that we're not, and we're like a separate breed. You yourself can also introduce logical errors in your program. Okay, the next sort of big source of exceptions is trying to access resources that don't exist or aren't available. So imagine that you're trying to connect to a database, and maybe that database doesn't exist, it's called something else. The other option could be that the database is busy, it's kind of busy serving something else. What do you do then? So yeah, third most sort of frequent situation. Of course, you could also just run on a resource you already have. So if you try to load the entirety of Wikipedia into your persistence memory, I believe all languages is about some massive amount of TB. You probably don't have TBs or RAM in your system, so you could run out of RAM or system memory. And you could just lose your connection to resources you're already talking to. So that is another common source of exceptions. And yeah, there's the nuclear option, that is device failure. So if your system that you're running the program on fails for some reason, someone takes an axe to your PC or whatever, you probably will run into an exception if you're running something. My question to you is, which ones should we worry about the most, or which ones should we worry about more as a software developer? Yeah.
Logical errors?
Sure. Of course, you want to worry about logical errors because you're directly responsible for them. What about the others? Do we not worry about them at all? Do we worry about them a little bit? What's the idea?
I think user input is pretty important because, like, if we're trying to ship a product, we want to make sure that whatever we ship out, like whatever the user encounters, we want to be able to catch it and fix it.
Right. So coming back to the whole calculator example, you don't want to tell the user, don't use the 0 when you're trying to divide. But you'd rather just catch it and not tell the user what sort of trickery you're doing. So of course, so the first two we definitely want to worry about. What about the rest of the 4? Sort of important, very important, less important as programmers. Thumbs up for very high, kind of, not really. Kind of, yeah.
Maybe running out of resources, like we have to ensure that our code is efficient.
Right, so we definitely want to have in the back of our minds, okay, we still want to not waste resources. Okay, so we'll not talk about the rest of them. So basically, these 3 or 4 are the ones you worry about the most. I think that's what I talk about. So yeah, whenever you're kind of dealing with resources, these are the big sorts of things that we always want to worry about. If you're calling a resource, does it exist? If you're using a resource, make sure it doesn't run out, and of course user input and logical errors for the reasons we discussed. And yeah, so now we come to this important notion that there's a difference between errors and exceptions. So in Java, there's an actual class called error, and it's different from exception. And actually, so maybe the last 2, actually the last 3, will most likely result in errors before exceptions. And now the natural question, what is an error, right? Let's talk about that. So basically, errors are more serious exceptions, or problems, because exceptions are their own thing, that a program, or a reasonable program, a program that you would write, should not handle. So yeah, let me just get this all on screen so you guys can start processing it. The basic premise is that when someone takes an axe to your PC, you can't do anything about that as a programmer. That's completely out of your control. If tomorrow the data center floods and there is a hurricane, you can't do anything about that. There's no if a hurricane is existing, shut down sort of a thing. There's no premise like that. So you shouldn't handle them. Anyway, now we start talking about the actual differences. So whenever someone asks you, you know what to say. So obviously we talked about the first one. Exceptions can be handled by programmers and should be handled by programmers. Errors shouldn't. First difference. The second difference is that exceptions are possible to recover from. A lot of the exceptions that you'll see will not make your program crash and burn. There's a way to recover from them. There's a way to continue on, even if you suffer exceptions. In general, when you see an error, it's usually impossible to recover from them. This could be, your PC catching on fire. It could be, maybe the database, someone just comes in and pulls out a cable. What do you do then, right? So in general, this is a sort of guideline. There's always an asterisk to things I say, but in general, it's really impossible to recover from them. So yeah, exceptions can be checked or unchecked. We already talked about that. Errors are never checked because the idea is, why would you check if someone's taking an axe to your PC? Doesn't make sense. Usually will never happen. There's no point checking the errors. And the last thing, and this is the most important thing in my opinion, is that the programmer or the program is actually responsible if an exception occurs. If an exception has occurred, you have to deal with it as the author of the program. If an error occurs, it's usually the system's problem. Either the system doesn't have enough memory, or it's just crashed because someone took an axe to it, someone pulled out the plug. It's not the program's fault. It's because of reasons beyond your control. So you never have to worry about errors in general. That's the basic idea. Any questions so far about these things? If not, let's move on. Okay, so the one thing you want to know about exceptions before we actually look at some is the throwable class. So exceptions and errors in Java, remember this is now Java specific. Exceptions and errors in Java are both derived classes of the throwable class. So let's look at that. And basically the idea is only instances of the class throwable or its subclasses, so not just the class throwable but also exceptions and errors, can be thrown by the JVM using the throw keyword. If you remember, does anyone not remember what the JVM is? Do we need to refresh? Okay, cool. Okay, so we introduced the concept of the throw keyword. This is something to look at in just a moment, but you just want to remember throw is something you can do with an exception and an error. Usually you don't worry about errors. Okay, so yeah, the basic idea is that if you want to manually throw an exception, you use the throw keyword. And I understand that I'm using the word throw an exception, and I'll tell you what it is. But you'll see in just a few minutes. That's the basic idea. That's all you need to know for now. Oh yeah, and I'm also sort of hinting at this thing. So if you're throwing an exception, you can also catch it. And you'll understand what we're talking about in just a second, but you just want to have this sort of thing going on in your mind where you can throw an exception and you can also catch it. For now, that's all we need to know. All right, before we talk about that, we want to talk about why bother with exceptions at all. So, why would we want to do exceptions now that we know all of these things that we discussed? We've already discussed one, so that should be easy. Anyone? Yeah.
Like edge cases.
Mm-hmm. So essentially we want to kind of model those situations where things go wrong, right? That's what we talked about. Why else would it be useful to have exceptions? And you want to start thinking about everything else we talked about in terms of design, in terms of best practices, and solid principles. Why would you want to do this?
It makes things a bit easier to debug because you
Right.
know exactly what's happening.
Right, and there's a word that starts with M that I keep repeating in class. Yeah.
Maintainability.
Exactly. So exceptions help with maintainability. You can guess that there's another word that starts with T called testability that goes hand in hand. If you introduce exceptions, you're helping a program be more testable. Anyway, I won't spoil the surprise because there's only 5 participants today, so let's not bother you until everyone answers. Anyway. So the first thing first that we already kind of talked about, we want to know when we run into edge cases, we want to know when there's problems. Second thing, we actually want to have a model to avoid these problems. You haven't looked at this yet, but that is the second reason. Because of course, when there's a problem, you want to solve it. The third thing is, you want to report these issues as they come up. It's called error reporting to help debugging. And this might remind you of the example that you looked at where, if you saw in the output, trainee dog is null. It's always helpful to have helpful error messages when things go wrong. And the most important reason is to basically avoid doing meaningless work. And can anyone give me an example of when this might be a thing? We can go with the dog example. So think that we've initialized a dog and we want to then do some operations on the dog. In that context, when would it make sense to do exceptions?
exceptions when the dog is null and we can't do anything with it.
Right, exactly. So if you remember, we had 3 fields. I think it was name, age, and can shake hands. So let's say you initialize the dog and then you want to train it, and then for some reason you make a mistake and you just pass a null. If you want to set its age and its name next, it's meaningless, right? Because those 2 statements will also error out. You can't do anything on a null dog. So this is an example of just 2 statements worth of work. You can imagine in more complex projects where there is a lot of moving parts and you're doing lots of work side by side, it makes sense to understand, okay, we can't do anything, stop all the work you're doing and just tell the user instead of doing all of this meaningless work. That's going to waste. So yeah, that's the 4th point about why we want to bother with exceptions. And now we come to exception handling. So before we talk about handling exceptions, I will stop for questions. Any questions about exceptions so far? Clear as mud? Okay, so we've talked about problems and when things go wrong. We have to talk about the solutions, right? So let's talk about that. We've already kind of talked about when you solve the problems that arise with exceptions, we call that exception handling. All right, so I'm going to go straight into code, and the next 20 minutes or so is just going to be code. So we want to put on our programmer hats, and it's going to be a lot of interesting stuff. Okay, so let's talk about some exception handling. Right, let's go here. Okay, we're still going to use the same dog class, so I should probably remove this output, that is irrelevant. Okay. We're still going to use the same dog class, so it's still the same setup. We still have a name, we still have age, we still have a boolean can shake hands. Dog is the same. The first thing you might notice that is different is this. Throws, that's the keyword, I kind of into that. And we see the exception name called dog not initialized exception. So any guesses as to whether this is user-defined or built-in?
User-defined.
Right, because Java doesn't want to have a built-in function for this. Cool. So, how have I defined my own exception? Super simple. Anytime you want to make your own exceptions, you use the extends keyword. And of course, extends means inheritance. So, inheritance from the exception class. And if you look into the exception class, it actually extends throwable. So I wasn't lying to you, it actually is a derived class of throwable. And if you click into that, you'll see the only other thing we're talking about is errors. But anyway, we don't go into that. Okay, coming back to our exception. So I define an exception called dog not initialized exception, which extends the exception class. Remember, you have to do that, otherwise your exception doesn't count. Okay, so, and the only real thing you then have to do is create a constructor, excuse me, with some sort of string, and you can call the string whatever. I called it message, and you can just say super of message, and at that point, you will have your own user-defined exception with all of the goodness of what an exception should do from the power of inheritance. That is how you define a user-defined exception. Let's go back. Okay, so we see that our train dog method now throws a dog not initialized exception. So whenever you see the keyword throws next to a method, you want to understand that, okay, at some point in this method, that particular exception might be thrown. That's all you're trying to understand. Okay. Now we know at some point this exception is going to be thrown. Now we can start looking at the code. Okay, what's going on? These 4 lines should be hopefully familiar. It's just the happy path. If your training dog is not null, then you set the can shake hands to true. You just return it. We're all happy. The world is all a lot better roses. Okay. What happens if things go wrong? That's, of course, where exceptions come in. In the else block, now I'm throwing a new dog not initialized exception with the message training dog was not initialized, so some sort of helpful message. The one thing you want to remember and to notice is compare this to when we're not using exception. We have to return a value when the precondition was not honored, right? So for our divide, we had to return 0. For our trained dog example, we returned null again. When you throw an exception, it's kind of understood. Things have gone wrong. And you don't have to return some sort of meaningless value to kind of indicate that things have gone wrong. The expectation is that this exception will signal to the program, okay, something's gone wrong, stop everything, look at how to deal with this first. No need for a meaningless return value if you throw an exception. All right, that is that. And you might be wondering, so okay, I can throw one exception, but what about many exceptions? Because of course, there's more than one type of problem that can happen in a program. And indeed, we can throw multiple exceptions. We just append commas and we talk about different exceptions. That's how you would do multiple exceptions. We won't look at the code just yet because it'll just confuse you more. What we want to do is go right into the main and start looking at some code. Okay, so we're in the main function now. We're still creating a new dog called Scruffy. I think the age is still 1. We're just printing it out. Anyone can sort of talk about what's going to happen. It's going to be a dog with age 1 called Scruffy, can't shake hands. Okay. Now, the interesting thing is you can't call a function that throws an exception. Oh, I uncommented a comment by accident. Right. So, if I just try to call this method that throws an exception, the same way you call any static method, your IDE will shout at you, and actually this code won't compile at all. Why do you think that is? We just added the notion of throwing an exception. But we can't call this method the same way we would call any other method. Why would that be the case?
You have nothing to receive it, so
Right, so there's a case where things go wrong and that we haven't addressed. What happens if things go wrong? We just say, you know, there's an exception and someone has to deal with it. You can't have a method that kind of raises their hand, like, okay, something's gone wrong, someone has to deal with it, and then just kind of call it the same way. So, because this sort of method is dangerous, something can go wrong, we've already identified that. So, if you look at the error message, it says, the text is very tiny, so I'll just read it out for you. It says, unhandled exception, and then it basically says dog not initialized exception. The ID is trying to tell you there's an exception that hasn't been handled yet. And if you think about it, that makes sense, because where are we taking care of the path where the dog is not? We haven't really done anything, right? So, we comment these lines out, so we can't really do it this way. We have to introduce 2 new keywords called try and catch. Let's first look at a try block. This might look familiar. We're trying to do the two same things, two identical lines of code. Same thing we were trying to do before. Only difference is that there is a try around it. So basically, whenever you see a try, the only thing you need to think about is, okay, whatever's happening inside this try block has a method that can throw an exception. That is essentially the syntax. That's what Java is trying to tell you. The next block is the catch block. And the first thing you notice, we catch the exception that we defined. Okay, so we're catching the exception, but on its own that doesn't tell us anything. What are we doing inside this block? That is what is interesting. So the first thing you might notice is this print statement called exception caught. This is just to kind of help us understand that the exception has been caught. The next thing you might want to look at is this print statement, which actually prints out the exception message. So whenever you catch an exception, you can call e.getMessage, and you can just get the error message if you only want that. And the third line, and the one that you'll most often see in your software careers, is e.printStatTrace. And this will give you a stat trace, which I'm sure you guys probably don't know what it is, to help you debug what has gone wrong. Anyway, so all you need to know for now is if you see a try, something in that throws an exception. And if there's a try, then you have to catch that exception in a catch block and do some sort of handling of the exception. Right now we're just saying, okay, exception happened and then just run. But you could also have different things going on in more complex programs. So now we know try and now we know catch. Any questions so far before I introduce more weirdness into your lives? No questions? Okay so far? All right, okay. So now we looked at try and catch. We've looked at how to define our own exceptions. And we've looked at how to signal to different programmers that, okay, we're going to throw this exception in this method using the throws keyword. Let's look at what happens next. Right, so the next thing I want to talk about is this. So if you remember, in this catch block, we're actually naming the exception that we're catching, the exception that we're handling. You actually don't have to do that at all. So you can just do something like this. Catch exception E. And remember, exception is a class in Java. And so this is essentially a catch-all catch block. So any exception that happens, we don't care what it is. It could be a dog not initialized, it could be an arithmetic exception, it could be an illegal argument access exception. If for all the problems in the world, you just want to do the same thing, you can have this sort of catch-all catch exception, where you just do the same thing regardless of what exception it is. That's it. So you could do that. Now, let's look at this. I think I haven't introduced this function to you guys just yet, so let's look at this one. Okay, yeah, so now let's look at this function that throws two exceptions in the same method. So remember, the first one should be the same, it's dog not initialized. The second one is called illegal argument exception. That is a built-in exception, I didn't come up with it. What is happening in the method? Now, I've got an additional check. The first thing I still check for is whether the dog is null or not. That's fine. If the dog is not null, then I'm still checking about its age. If the age of the dog is less than 0, I'm throwing a new illegal argument exception. A dog can't have negative age. Make sense? Should make sense. If that's true, then you throw an exception, otherwise you still do the same thing, set the can shake hands true, and return trained dog. So remember, it doesn't have to be an else block, you can have throws in if blocks also. Else should be the same. You're throwing an exception in the else block, should be fine, we're all good. The only new thing essentially is you can throw different exceptions in different parts of your same method, depending on your use case. Cool, so that is called stricter trained dog. Stricter because there's an extra condition of the age not being negative. Let's go back to our main method and see what happens. Okay, so we looked at how we have a catch-all. Now let's call our stricter trained dog. Okay, let's try and pass in a stricter trained dog with the name Pumpkin. The age is -1. We are going to run into an exception. So, when you want to catch 2 different exceptions, or for that matter, any different number of exceptions, but not everything, you use this syntax. You know that there's going to be 2 exceptions, dog not initialized or illegal argument. You use this OR pipe operator for that. And then you can, of course, club this behavior for handling the exception. That's still the same. Let's see now, anything else? Oh yeah, so one last thing. Finally, we come to finally. I actually prepared that. I wanted to say that forever. Anyway, so we have a try block, we have a catch block. There's actually a 3rd type of special block we can use. It's called finally. Any guesses as to what it does? You could just read the code, or you could kind of guess yourself.
It runs no matter what.
Right, so regardless of whether you execute a try, you catch an exception, sometimes you want to do some things that happen regardless of whether you successfully executed the try or you caught an exception. That is when you use your finally block to run after the try catch block. So the basic guarantee is that unless an error happened sometime during the try catch, the finally will execute after the try catch block. And that's where you put in all the stuff you want to execute finally. Usually, finally is used for stuff like cleaning up connections. Let's say you're connecting to a database, at the end of it you want to close a connection, right? Just to clean up after yourself. So stuff like that would go in a finally block. Any questions before we run the program and explore more? Okay, looks like we're okay. Let's run this program. Okay, so lots of things are happening. Let's keep about the output at half and half. Let's scroll to the top. Cool, so the first line, second line should be, okay, we've initialized the dog called Scruffy, we're printing it out. And of course it's false by default, so that is all fine. Now let's look at what happened. So we have tried to do this. We try to train a new dog. If you remember, new dog is Scruffy, has an age 1, it's not null, so it will successfully train. That is what you see. So this try has executed successfully and it corresponds to this line of output. So far so good. No exceptions here, no sir. Okay, so this catch block is basically useless for us. Nothing wrong happened. We're all good. So nothing happened in that catch block. Now we come to the source of our problems. We're trying to train a dog, which is null, and of course that is bad. So when you actually call this line, inside, remember, we'll come to this line and throw a new exception. So when that happens, this exception will be thrown, you'll actually never reach this line, and you'll come into this catch block right here. What's going to happen? First thing we always say is exception was caught. So that is why you see this line. That corresponds to this one. We're printing out a message. Trainee dog was not initialized. Makes sense. We're trying to train a null dog. And the stack trace seems to be missing. We'll get to that in just a second. Okay, so stack trace is somewhere. We have printed out these two messages from this catch block. Cool. So the first thing you want to remember, we've already had an exception. Things have already gone wrong. We're still going to get to this try block. The program has not crashed and burned. We're still running. We have had some problems. We've handled them. And now we can continue with our same function. So we're actually going to come to this try block. And of course, we're being naughty again. We're trying to set a dog with negative age. A different problem is going to happen. We know which one. And the message is dog age cannot be negative. Fairly obvious. Same sort of thing. You try to train a dog with negative age, you're going to end up in a catch block, and you're going to print out these two lines. Simple stuff. Okay. So this is the interesting thing. So now, what if we do two bad things at the same time? We're trying to first train a dog that's null, and then we're trying to train a dog which is not null, but has negative age. So do we see the exception twice, or do we only see one? Let's see what happens. So we get the exception caught from here, that's fine. And what is interesting is we only see the message that trainee dog was not initialized. This is something new. So if you encounter an exception in a try block, you're not going to execute the whole try block. The first time you see an exception, you're just going to go, okay, no, there's a problem, and you come to the catch. That's why you don't see the second exception also thrown, because you never got to that point. That is something you have to remember. And of course, right after this, we have a finally block. Finally block executes, regardless of whether there's an exception or not. So finally block will always run. So far, so good. Now we see some scary red lines. You can just start to peek. Okay, what is this? So this is called a stack trace. So remember this line at the end, which somehow had no output. All of the stack traces from all of the exceptions that were thrown have actually been put to the end. There's a reason for that. You guys can find out, I won't tell you. But anyway, for some reason, the stack traces are all at the bottom. For one exception, let's go back to the very top. Okay, first time we didn't throw an exception, so second time, right here. So remember, we said we printed out the exception message, and then we printed stack trace. For the stack trace, for the first catch is this, just these two lines, three actually. What is a stack trace then? It's essentially trying to tell you where the exception happened. So imagine it this way, right? Let's start looking backwards. So the first thing we see is the dog with exceptions, dog trained demo, dot main. What that's telling you is it all started with the main. That's at the bottom of the stack. So we're running the main function, which you remember is running all this code. And that's at the bottom. Okay. What happened inside the main? Inside the main, we call this method called train dog. So that comes next on the stack. We're inside the main, we have to run this other function. So inside the main, we were running train dog. That comes next on top of the stack. It's basically a way to remember, okay, how far along are we and where does it all end? Where are we all coming back to in the end? So you see main, inside that we're running train dog, and inside that, after that we don't see any other methods. So what that means is the exception happened inside a train dog. And what was the exception? It was dog not initialized exception. That is how you read a stack trace. You basically, you look at the exception, you could go downwards and that'll tell you, okay, what sort of levels you're going through, or you can go backwards. Usually we go this way because it's easier to see what went wrong and then where it is. That is a stack trace, and all of the stack traces actually are here. The other thing you might notice is the difference in the stack traces when you use a user-defined exception versus a built-in exception. So you can obviously see java.lang.illegal argument exception. That's because it's a built-in exception. Anything else will be user-defined. So you can actually tell just from a glance which one is user-defined and which one isn't. I think that concludes our very, very lengthy demo. I think it's the longest we've had. Questions about exception handling? Nothing? Just drank it all in? Okay, no worries. In that case, let's get back to the slides. Cool. So, obviously, after a demo, we have to remember some things. There's going to be a lot of things to remember. Let's get started. So, we want to remember the first thing is we use a try keyword to enclose code that may throw exceptions. You could technically use it and not throw any exceptions, but why would you do that? Catch is used to indicate what to do when an exception occurs, usually maps to a try block. And of course, we can use finally to execute code that should execute regardless of whether we ran into an exception or not. Simple enough? And of course, we looked at how to throw exceptions using the throw keyword. Essentially, when you want to manually say, okay, there's a problem, you use the throw keyword. And we can actually tell different programmers and the JVM, okay, this method will throw these exceptions using the throws keyword. And we also saw we can throw as many exceptions as we want. So we only looked at 2, but you can have a whole list of exceptions to throw. Of course, if you have a method like that, no one would want to use it because there's too many things that can go wrong. But yeah, you can do it if you want. And of course, we can define our own exceptions. Okay, so nothing too difficult, hopefully. It is quite hard to digest if you've never really looked at it before, so please do take the time. But yeah, so before we actually discuss what to do with the code snippets that we talked about, we're going to talk a little bit more about stack traces. So the JVM actually behind the scenes is helping us handle these exceptions. So you might be wondering, okay, does it automatically go to the cache nearest to it? No, it has to kind of figure that out, right? So how do we do that? Okay, so basically the JVM starts, whenever an exception happens, it starts looking at the call stack. This is the same thing you might see as a stack trace, what we just looked at. So what the JVM wants to find is a method that can handle this exception. So if you remember when we say catch exception name, we're basically telling the JVM, okay, here's a method that can handle the exception that you're trying to handle. So if you've thrown a dog not initialized exception and we see a catch dog not initialized, JVM is like, okay, I found my method, here you go, you do whatever you want with it. At that point, it's done. Okay, and yeah, we already talked about call stack, so it's basically the same as stack trace, just in a different order. It's basically a list of methods where you're kind of trying to figure out, okay, how do we get to this exception? Cool. And yeah, we basically start from the reverse, so it's going to go, okay, train dog has this exception, where can we find the first catch? So we work downwards, basically, the exception name and then towards main, if you remember. So, like I said, if you find an appropriate catch block, all is good. You hand it off to that, well, you as the JVM will hand it off to that catch block and its job is done. What happens if you have not handled the exception? Sometimes things go wrong. Maybe you have a logical error, you just forgot about it and you didn't write a catch block. What happens then? Well, they thought about that too. If you haven't used a catch block, then you're going to use a default exception handler. And you never want to do that because the default exception handler says, oh no, this is catastrophic, crash and burn the program, you can't go any further. You never want to do that. But in case it does happen, that's what happens. Okay, oh, sorry. Questions about this? Okay, so far? Alright, no worries. Okay, let's talk about a few questions that you may have. So the first one. Can we have multiple catch blocks or one try block? Yes, no? $50 yards, doesn't get better than that.
Yeah,
Okay, why would that be?
if you wanted to catch different exceptions.
Yeah, exactly. So there's always scenarios where you want to do different things or different things are wrong, right? So it makes sense to have different catch blocks for one try block. Can we have multiple finally blocks for one try block?
No.
Okay. Why do you think that is?
It's because usually finally is going to run anyway, so it's just going to have one.
Right,
That
right.
makes sense.
So if you it kind of defeats the purpose if you have multiple finally blocks, right? So yeah, you cannot have multiple finally blocks. And yeah, so please do play around with this code snippet. Exception handling is an art. You will be doing it essentially every day. And these are just two examples of questions that you might have. So I encourage you to please explore more about exception handling. Okay, if that's that, then that's all I have for you for exception handling. So before we talk about logistics, any last questions? Any final thoughts, comments? Is exception handling fun? Is it not fun so far? First impressions good? First impressions bad? Just pause for a good 10 seconds, just take it all in. Okay, if not, that's all I have for you for today's class. We're going to talk about a few logistics. So the first thing we want to talk about is your phase 2 UML diagrams have been graded. I think all of you did good, so I don't think I docked any points this time. You might still have a few issues. I think there's two I want to talk about. Right, so the first one is on your GitHub repos. I don't know how many of you did this, there's only 5 of you. But yeah, so if I've left an issue, whether it's a nit or another issue, either way, whether you address it or not, just say, okay, I addressed it, we think this is the right way to go, and close it. Otherwise, it kind of seems to me that you haven't looked at it at all. So if you have outstanding issues, please comment on them and close them either way. And yeah, the new issues that I have put out on your repos, maybe you have none, maybe you have one or some. You want to address them by the source code deadline. That should be 2 weeks from Tuesday, so it's coming up soon. Yeah, so speaking about that, the source code assignment is now published, so you can see the deadline. As before, it's 15 points, so it's worth a little bit more than UML diagrams. I wanted to remind you that this phase 2 has the optional requirement of tests. So you could implement the tests for everything you've done so far now, and have less to do in phase 3, or you can push it out to phase 3 But remember, if you do push it out to phase 3, then you'll have to still do it. It's just a question of when you do it, not whether you will. And the final reminder is, of course, quiz 2 is 1 week from today. I'll send out an announcement in Canvas a little later, just to remind you guys. But yeah, that's that for logistics. With that, we're done for today's class. Thank you for coming out. You are the lucky few who will get to see this class, because this is actually for evaluation purposes, not for the benefit of the class. So yeah, if you didn't show up to today's class, then you missed it. So congratulations to you lucky few. But anyway, that's all I have for you guys. I hope you guys had a good Halloween. I hope you guys had a good time implementing phase 2, and I'll see you next class. All right.